Okay, what's up, what's up? Today we're doing another Leetcode problem, k closest points to origin. Given an array of points where point sub I is x sub I, y sub I, represents a point on the xy plane and an integer k, return the k closest points to the origin. The distance between 2 points on the xy plane is the Euclidean distance, the distance formula that we, all know and love, hopefully. Just kidding. You don't really like it. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. So here we're going to get into the question. We're going to define a distance function where we pass in a point and we return an integer. The reason why we're going to return an integer is because we're just not going to do the square root. Any number that is greater than another number, when you square root both of them, the order's still going to stay. So we actually don't need to handle that part, right? So we can just do this. Return point sub 0 squared plus 0.1 squared, right? And that's a very valid way for us to write the distance formula here. And so here we're going to create a heap, which is we're going to be creating a list, right? And then we're going to be holding tuples in it because we can't just hold the point because there's nothing for it to be ordered on, right? So now we're going to create a max heap because we want the biggest distance at the top, which is what we can pop off and throw back on. We're going to do negative self.distance points I, and then we're going to give it I here for I in range of k, right? So for that amount of numbers, that amount of points, we're going to create this tuple where we get the negative distance of the point from the origin, and then we're going to give it the index in the tuple, right? So that's our heap. We're going to do heap q.heapify heap because we need to heapify it to make sure the largest distance is at the top, stuff like that. And now we will handle the rest of the points. So for I in range of k to the length of points, we're going to be checking, we're going to be holding a temp distance is equal to the negative of self.distance points I, right? Oh my god, my keyboard double registers all the time. I'm gonna get rid of this keyboard hopefully soon. Temp distance, and then so if the temp distance is greater than heap 0, 0, because this is the first index of our heap, which should have includes the largest distance, and this is the largest distance, right? So we're going to be popping off heap q.heap pop. We're going to pop off of heap, and the heap q.heap push. We're going to push onto heap temp distance and I, right? Because now we found a distance that is actually closer to the origin than the first item on our heap, which has the furthest distance, right? So now we replaced it. And now, so after handling all of that, we now know that after handling every point, that our heap contains all of the points with the closest distance, right? So now we want to return a list of which we have points I for blank, because we don't actually use that first item. I wait, yeah, why do I have this first parentheses actually? So we just want to fill the array with points I for blank comma I in heap, right? So basically this will go through everything in the heap, right, which looks something like this. We're going to ignore the distance because we don't need that in our final solution. And then for whatever I it is, we grab the value from points sub I, and we put all of that into an array. And that's how we would build out this solution. And this is how you would solve k closest points to origin with the top k method, right? And so if we were to submit the problem, let it run, there we go. It works. So yeah, with that being said, thank you so much for watching, and I guess I'll catch you some other time.